Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, we will be solving a problem on friction. The lecture number is 3-3 and let us look at the problem here. A system of blocks is given. Let us see, you have block A, block B, block C and he is asking what is the minimum force P required in order to have the motion in the direction of the external force. That is the problem. So, find the least horizontal force P to start motion of any part of the system. That means either it may move only block A or maybe A and B together or A, B, C three together. So, you have to calculate the magnitude of the force P, which is least force, that is minimum force, in order to have the motion in the direction of the force. This is the problem, and to solve this problem we will be drawing the free body diagram of the procedure is like this. Let us draw the free body diagram of A alone and calculate the magnitude of the force P required. Let us see that here the coefficient of friction between A and B is given 0.3, which is having relatively more value of coefficient of friction. And then assume that case 2, A and B together is moving in the direction of the external force, then the coefficient of friction is given 0.2. And lastly, let us assume that A, B, C three together it is moving in the direction, and let us draw the free body diagram of three together and calculate the magnitude of the force P required in order to have the motion in the direction of the force. So, this is the problem. So, you will be solving in 3 steps. So, your case 1 is, case 1 is you are assuming that free body diagram of A only. So, that means it is you are going to draw the free body diagram of block A. That is your first step, case 1, and draw the diagram of the block, and weight is given WA, the magnitude is given 300 newtons, WA is 300, and let us assume that the normal reaction offered by B upon A. So, let us write down this as NA, the reaction on A block, and the motion is to the right and frictional force is opposite to the direction of the motion, that is this is external force P, and this is the coefficient of friction is given 0.3 times the normal force is the frictional force. So, this is the free body diagram of block A alone. This is block A only. So, now let us use equations of equilibrium and calculate the force P required with A alone. So, first you write down sigma Fy is equals to 0, sum of the forces. So, simply Na is equals to 300, Na is equals to 300 newtons from sigma Fy is equals to 0 equation. Then you write down sigma Fx is equals to 0. So, sum of all the forces along the x direction. So, that is P is positive and it is a 0.3 times it is Na is 300 is equals to 0, and P value 0.3 into 300 is 90 newtons. So, this is, let us record this value. This is with case 1, that is P value is 90 newtons. Let us consider second case, A and B together is moving in the direction of the external force. So, let us draw the free body diagram of a connected system of 2 blocks. So, you are going to draw, this is the free body diagram. So, let us write down case 2 is it is a free body diagram FBD, free body diagram of block A and B together. So, the weight of A, which is 300 newtons downwards, and the weight of B, that is WB, is given as 100 newtons. This is the WA, and let us draw the free body diagram. Normal reaction on B, that is NB, and external force is to the right, that is P, and frictional force is this coefficient of friction is given 0.2. So it is 0.2 times NB. So this is the free body diagram of two bodies A and B together if it is moving in the direction of the external force. So now you apply sigma Fy. So NB is equals to 300 plus 100, that is 400 newtons. So by writing sigma Fy is equals to 0, you are going to get NB is equals to 300 plus 100, that is 400 newtons. Sigma Fy is equals to 0. From that equation, NB value you got it, and now you write down sigma Fx is equals to 0. Sum of all the forces, that is P, is equals to your 0.2 into NB, that is 400, and the value is 80 newtons. And observe carefully, this value is less than the first case, that is, so before going to move this block A alone, so two together it will be moving in the direction of the force. Let us see the third case also. Your third case is case 3, that is free body diagram of blocks A, B and C together. A, B, C two together. That means you have to draw the free body diagram of the whole system. That is block A. Weight is it is 300 newtons downwards. This is A, and block B, WB, that is 100 newtons downwards, and lastly you have C also. So WC, this is the WC, and that value is 200 newtons. All three are represented downwards, and the reaction offered by the ground upon C. So that is let us write down N, that is NC upon C, it is NC, and the frictional force is, it is given that coefficient of friction is the lowest value, that is 0.1 times it is NC, right. Now you write down sigma Fy is equals to 0. So if you write sigma Fy is equals to 0, so this equation gives you NC is equals to 300 plus 100, 400 plus 200, 600. So NC is equals to, it is 600 newtons, and write down sigma Fx is equals to 0. So this equation is your P is here, P is equals to, it is P is equals to 0.1 times, so that is 600 newtons, and this gives you 60 newtons. So which is among all three cases lowest value? Observe carefully, 90 newtons, 80 newtons and 60 newtons. So 60 newtons is the lowest value of the P value required to have the motion in the direction of the external force. Obviously that means you are going on increasing this P value. Let us assume that from 50 you have started, and the moment you 50 value you increase it to 60, the whole system moves in the direction of the external force. So there is no chance of reaching 80 and 90, because the moment you apply 60 newtons, the whole system will be moving in the direction of the external force. And here the conclusion is that the moment you apply the force P, because of the coefficient of friction, lowest value of the coefficient of friction between the ground and block C is 0.1. Because of this reason, the whole system, means the block A, B and C together, it will be moving in the direction of the force. The conclusion is that P value, the answer is P value is 60 newtons, at which the body is moving in the direction of the external force. Thank you very much for watching this video.